Greetings and salutations. Welcome to a video about audio. Today, I'm going to show you how to create stellar sounding MP3 files from CDs using open source software on Linux. This is my Linux Mint Debian Edition 6 desktop. That is codename Faye, but this should work on just about any distribution of Linux, as long as things are set up in the background the way they should be. So in this video, I'm going to mainly concentrate on CDs and MP3s, but as you go along, if you're wanting to do this and you're wanting to store your files in some other format like FLAC, or you want to put them in Opus or OGS or whatever, for whatever reason you want to do it, that's fine. I have some reasons why I use MP3, mainly because I've used it since the format was introduced, and I have thousands and thousands of MP3 files already. And there's some neat tricks that you can do with an MP3, which I will show you later on, that other file formats can't do. Before we get into the technical side of things, let me take just a moment to give you a little bit of background. If you're new to the channel, you don't know who I am, you're probably wondering, why does this guy think he can tell me how to create digital files, and what does he know about digital audio anyway? Well, I have spent most of my adult life in radio. I started in the mid-'80s, and back in those days, digital audio was a CD player. That was it. And everything else in the radio station was analog. When we created a music library, we usually put it on tape. They were tape cartridges for radio. Broadcast tape loops, in other words. And I did that for years. You'd take CDs and records and record that to that. And then digital tape recorders started to show up in radio stations. And then in the 90s, we started to see automation systems where the audio was served from digital files. So therefore, I learned how to do that, and I maintained libraries that way. As a matter of fact, I'm still doing that today for the radio station that I work for now. And we're going to touch on that as we roll through. I'll explain the differences between what I'm doing for my own library and what I do for the radio station as we go along. I guess the other thing to talk about is the elephant in the room, and that's why anybody would want to do this in 2024. Don't we have streaming sites? Isn't everything available at your fingertips at all times, and we don't need to actually have a file or physical media anymore? Streaming sucks. Streaming sucks on many levels. First of all, you have to endure all the commercial content and the subscriptions and all the crap that you have to deal with. And streaming services aren't very good at holding on to stuff that you like. This is especially true with music, because you could create a playlist, let's say on Spotify, and then a month later come back and half the stuff is gone because Spotify, for whatever reason, has decided to no longer offer that. It could be a dispute with the artist over royalties, or just that they decide, well, nobody really likes this, so let's make it go away. A lot of streaming services are doing that because that conserves storage space and bandwidth for them, see? Sucks for the people who are subscribed to their service. So if you're a real music freak like I am, and I am a music freak, then you want to maintain your own library. And the way I'm going to show you how to do this is not how you should do this. This is how I do it. And like I said, I am a music freak. I am an obsessive-compulsive music nerd audiophile type person. I want control over every step of the process. So what I do is use very simple tools to do simple tasks, and I put them together to get the end result that I'm looking for. I do not expect one piece of software to do all of this in one go. They just don't exist anymore. Way back a long time ago, when MP3s were new, there was a lot of open source software out there, or paid for software, that would automate everything that I'm showing you that I'm doing. Audio Grabber is one that comes to mind. That was a piece of software for Windows. It's not on Linux. So we can't do it that way. And of course things change through the years anyway, so it's like this way you can adapt to the change if you do it in steps. So let's get started. Let's talk about the technical stuff. What are you going to need to do this? Well, the first thing you'll need is some CDs that you want to convert to audio files. And the second thing that you're going to need is a DVD player, or a DVD burner, rather, is what I'm looking at in your machine. You notice I didn't say CD burner because you really can't buy just individual CD burners anymore. If you have a particularly old machine that's got a really good CD burner in it, you might be able to use that. But a lot of machines these days, we're talking about desktops, don't even have any kind of optical media at all. Now, if they have 5 1/4 bays, you can put one in, and that's what I suggest you do. And the ones that I have found to be the most reliable for this job are the generic light-on DVD burners, and this is what they look like. Okay? And they were standard issue in just about every Dell and HP PC that was made for the last, I don't know, 25 years maybe. When did they start putting DVD burners in the computers? It's this model, and they're available for about $25. You can get them on Amazon. If you don't have one, get one. If you're using a laptop and it's got a built-in DVD reader and writer in it, one of those slim lines, it'll work, but it's not going to be as reliable. And if you have any trouble discs that are damaged or they weren't pressed quite right, those kinds of drives have a hard time reading them. So if you're getting a lot of read errors on that, that's why. It might work in a more standard CD recorder. At the end of this video, I'm going to show you how to do this the simple way. We're going to do it with Rhythmbox, which is the GNOME music management software that comes with a lot of Linux distributions, or you can download it if you want to. And it'll do about 90% of what I'm going to show you. And then you can add one little tool that I'm going to show you to the mix at the end to get almost perfection. But let's start with the absolute simplest way there is to get an MP3 file on just any audio file from a CD on a Linux machine. We're going to just show you the quickest, dirtiest, easiest way to get audio off of a CD. Now, I just put a CD in the drive, and it's a Sean Colvin Sonny Came Home promo CD that I got from a radio station years ago. I have tons of these. It only has 2 tracks on it, and it's good because it will illustrate a couple of points here. So when you put it in, you see this come up on the desktop, and you click on it, and you open it up, and it opens in a file manager, and it offers to open Bracero. I'm not really sure why it does that, but it does. Bracero is on this machine. That's a open source program to write DVDs and CDs, which is beyond the scope of this video. I might do one on how to create really cool mixed CDs. If you want one, you guys let me know. So what you're going to see here is that it says that there are 2 WAV files on this disc, and they're labeling it track 1 and track 2. In reality, there are no WAV files on the disc. Audio CDs, Red Book standard CDs that you play in a CD player, do not have files on it. What they have is one long stream of digital data that starts in the middle and works its way out to the edge. It's just raw pulse code modulation. That's all it is. And we have to put that in a file in order to make use of it in the computer world. The desktop here is kind of making it easier to work with that information on the disk by saying it's a WAV file. And because it says it's a WAV file, I can do a couple things here. First of all, I can drag it to my desktop, and now I am copying track 1 WAV to the desktop. And what it's doing is it's ripping the disk in the background. It's taking the data from the disk and converting it into a WAV file format that it's going to put on the desktop. And so therefore I can now take this WAV file and open it up and work with it and do whatever we need to do, right? So, and it's taking a little while because in Linux, CD ripping is usually done with a program called CD Paranoia. And CD Paranoia, when set up properly, will find the fastest speed it can run the drive at and still get no errors in the data stream. And so sometimes that's slower and sometimes that's faster. We'll talk more about that in just a little bit. Because these are being represented as WAV files, I can also go in here and choose to open it in Audacity directly, not directory, but directly. Words, they're hard. And so what Audacity is doing is it's taking the data that's being ripped into that WAV file as we opened it up, and it's putting it in its own temporary file, and now it'll come up on the screen here. So this is a quick and dirty way to get audio off a CD. Very quick. And sometimes I use this, especially when I'm preparing stuff for the radio station. Sometimes I just need to grab one song, and so therefore I'll just take the CD, throw it in there, drag it over to a WAV file, take the WAV file, load it up in the computer that I use to work the radio station. You know, I've got a work computer, and I'll put it in there and load it into Adobe Audition and get it ready for being on the air. That's an entirely different process. So we have this song here, It's Sunny Came Home, and I'm not going to do anything to it right yet. I'm going to go ahead and just leave that file alone and get out, and I'm going to show you a little bit more streamlined way of ripping audio from a CD. And that is to use a ripper. And years ago, I changed the ripper that I used. I cannot remember what I used before, honestly. Can't remember the name of it. I've tried to remember. But I had to change it because the FreeDB database went down and I needed a ripper real fast, so I found one that used Music Brains. FreeDB.org may be back up and running again. I don't know, but I switched over to this one to use the Music Brain database in the background, and I kind of liked it. It's called Sound Juicer, and it's a little oversimplified, but it does what I need it to do. So I'm going to show you how that works here. So I'm going to put that in, and we're going to put a CD in. And I have in my hand Phil Collins' No Jacket Required. So we're going to put that in there and grab a tune or two off of that while we talk about how all this works. We'll let that do that in the background. It's going to take it a little while to find the disc. It's like I said, the player itself, the drive takes a little time. It goes through a protocol. Is this a DVD? Is this a CD? All that stuff. And then also this is going to go out and find the track information in a database. So that will take a little while. But while it's doing it, let's look at the preferences for this. And this is a very simple program, which I like and I don't like. First of all, you choose the drive. It says it's an unnamed drive. Okay, it works. I have it eject when it's done. I'm putting whatever it rips into the work directory. And then you have to choose a file name, kind of a template, how the file name is going to be constructed for what you get off the disk. What I do is title an artist. And I don't do a directory to put everything in for the disk. I don't do it that way. I just want the title, or the artist rather, first, and then space, hyphen, space, title. And if you do it like that, that's pretty standard, number one. And number two, later on, you can treat a whole directory full of files as if they were in a database, and you can use that separator, space, hyphen, space, as a way to tell whatever program that you're trying to get information into that that's the difference between the artist and the title. So that's how we do it. Here it offers to strip special characters that might interfere with file names. I don't worry about that. I just let it do what it's going to do. And then finally we get down here where we can choose what kind of file we want for an output. And on this one we only get a few choices, and we cannot change the options for anything that we have. That's hard-coded into the software. So if I choose MP3, it's whatever presets the developer of this software thinks that I ought to use. That's not going to happen for me. And there's really no way to change it. So what I do is, instead of these compressed formats here, I use FLAC. FLAC is stands for Free Lossless Audio Codec. And I use this when I'm ripping things for the radio station. Like if I'm going to rip a bunch of CD audio for the radio station, I'll put it into FLACS, and then I'll use the FLACS and import it into the system. If I'm going to do MP3s, well, I'll go ahead and do that anyway, right? Because then a FLAC being lossless, that means that it's not losing any of the original audio data. Whereas a lossy codec like an MP3 does that. So I can save it as a FLAC, I can edit it as a FLAC, I can do all kinds of stuff, and I'm not going to worry about re-encoding the audio back into a FLAC and losing quality. So let's choose a couple of songs here to get off of this album. We're going to get Sussudio, and let's do One More Night. And let's do Don't Lose My Number. So we're going to get 3 tunes off of this. This may take a little while. But while it is doing it, well, first of all, before we click go, let me explain a little bit about what you're looking at here. So the artist here says Phil Collins, which is fine. And then over here we have artist again. Well, that's the track artist. The software is smart enough, if you put a compilation CD in it, to know that track 5 is by a different artist. I'll show you that in just a couple of moments because we're going to grab something from a compilation CD here. When you are ripping files, you're ripping audio into files and you're working with groups like the Beatles or the Eagles or the Cars or the whatever, it is good practice to just cut the off the front because you don't want a whole bunch of files on your list and in your directory that start with the, because then it makes it hard to find things. Because do I look under the Cars or do I look under Cars? And some people do this thing where it's like Cars, comma, the. That's messy. Don't do that either. What the best way to go here is just to chop it off if you have to. And if you see anything weird with the titles that doesn't match up to the label on the CD, you might want to change that as well. So let's go ahead and extract this. How fast is this going to happen? Well, that depends on the disk, it depends on the drive, and it depends on how quickly CD Paranoia can grab the data from the disk and not have a high block error rate. I have noticed that original format CDs from the 80s, which I have a lot of, which were a 63-minute format for most CDs that came out at that time, they go slower than later, longer CDs. Why is that? Originally, when CD came along, there were 2 formats, 63 minutes and 74. The 63-minute format CD has a constant velocity of the surface of the disc under the laser of 1.6 meters per second. CDs use what is known as constant linear velocity. That means that toward the inside of the disk, it's going to spin faster, and toward the outside of the disk, it's going to spin slower. And that's because you can squeeze more data into the outside of the disk because it's a bigger diameter. Records don't work that way. They're constant, like regular records, that's constant angular velocity, which is a different thing. So CDs, the speed of the disk is set by the data itself. In other words, inside the data, it tells the system how fast to spin the disk to get it off of the disk. So that means there's flexibility there. A 63-minute formatted disk will have a 1.6 meter per second constant linear velocity, which equates to about 500 RPMs at start and about 200 by the end. And it will have a track pitch between the spiral little groups of little bits there, the data, the pits and lands of 1.6 nanometers per inch. There's like 22,000 tracks across a CD. It's amazing. And I've noticed that the earlier discs will run slower in drives like this to get the same amount of data without errors. Now, later on, they came out with the 74-minute version of the disc in the development because they wanted a longer version. The way they got that was they lowered the linear velocity under the laser down to 1.2 meters per second. They left the pitch alone at 1.6 nanometers per inch, or whatever that is. It might not be inch. That might be something else. You might have to look that up. I might be saying that wrong. But they left the pitch pretty much alone and just slowed down the disc. That gave them 74 minutes. Later on, in the early 90s, they started playing around with this idea of extending it out to 80 minutes. An 80-minute CD uses 1.2 meters per second constant linear velocity, and now the track pitch has changed to 1.5 nanometers per meter or inch or whatever it is. I don't think they would mix... I'm thinking records is what it is. I don't think they would mix their measurement schemes. I think that it would all be metric. But anyway, that's the idea. 80-minute CDs will play on first-generation CD players, but some of them have a hard time accessing tracks that appear after the 74-minute mark because it doesn't fit in with their logic. So, yeah, it takes a little longer to extract audio from early CDs, and the CD that we're extracting from right now is Phil Collins' No Jacket Required. I bought this CD in 1987, so it is not a first generation, but maybe a second generation, still using the 63-minute format. I can look at it and tell that by looking at the disc, and so therefore it's going to take a little while to rip. The advantage of having that higher velocity, of course, is spreading the data out more, and when the data is spread out more on a disk, there is less of a chance of a physical error causing a problem, and the data correction can fix that. So that's one of the big advantages. I just put another disk in so we could grab another couple of files, and it'll take it a few moments to figure out that that's what I've done here. And it will go and look up the disk. This is a compilation CD. Now, as far as this thing going up and looking up data in the database, most of the time it finds the disk. Sometimes it finds more than one candidate, and you have to tell it exactly what disk you have, what version of that disk, and that sort of thing. But most of the time it works. Now, this is a compilation disk. I'm going to just undo that so I can select none. We'll grab a couple of tunes off of here. How about we'll get The Power of Love, and we'll get Cars by Gary Newman. And you'll notice it's smart enough to figure out that it is a compilation disc and the artist's changed. So let's go ahead and extract this. This one might go faster. This is a newer CD in a little bit later format here. Yep. So this is going to go pretty quick. But I'm going to go ahead and pause it because you don't need to sit here and watch this happen. When it's done, we'll come back. Okay, we're just about finished here. Just a few more seconds left, and then it will eject the CD. It's done. CD disappears, and we're done with that step of the process. So now, what we have is a bunch of nice FLAC files to work with. And we're going to now go through the process of converting them to MP3s, and we're going to tag them, and then we're going to adjust the loudness on the disk. Not the disk, the files. We'll be using a little program called MP3 Gain, but I'm getting ahead of myself, and words are difficult today, boys and girls. I hope I'm making sense. So, the piece of software that we're going to use for this task is Audacity. So I'm going to go here and we will open up the work directory, which is where I'm putting everything. Now that thing that says screencast, that's the video we're recording right now, so I don't want to mess with that. All right, so we have, I ripped 3 from Phil Collins. So we'll start with ABC, The Look of Love, and we're going to open that with Audacity. And there it is. And you see that this file is extremely loud. So we need to normalize it. That's the first thing that we want to do. It's one of the reasons that I use an audio editor to convert, is because then I can run a normalizer on it. And what normalizing does is essentially it just sets the level to an optimum point at a peak level, that is, for the MP3 encoder. And the perfect level for that would be -1 dB from digital 0. So we're going to go ahead and do that. And you notice that comes down a little bit. So this is a disc that was obviously made after the, I'd say 95, 96 or so. Actually, this did come out in 95, and this was when the loudness war was beginning with CDs. Let's see if we could make CDs very loud. So they used digital compression and hard limiting to make things really, really loud, and so that's why you have this waveform that looks like a block here in Audacity. If we would encode this directly to MP3, we run the risk of adding distortion to it, because if we didn't pull it down a little bit, the MP3 codec will actually introduce overshoots into the audio. So with nowhere to go, it would just clip. Whether you could hear that or not, that's debatable, but it is definitely a thing that happens. So if we give it a little bit of room there, loudness-wise, then we have room for the overshoots. That's the idea here. While we're in here, we could also do things like we can check the how tight the front end is. Like on very early CDs, there's usually about a second of silence before the song starts. This is tight enough for me. You could tighten that up if you wanted to. Let's go ahead and do it. We'll just jump in here and just highlight that, and then boom. And so we've tightened that up somewhat. I don't like it right on top of it. You want to have a little bit of silence, just in case, for whatever reason, when you play it back, the player clips the beginning. You want to have just a little bit of room there. You could also, like, if it's a disc that's a live disc and there's audience clapping between each one, you might want to put a fade on it. You might want to edit the audio. You might want to take something out. It's up to you. One of the main things that I do this for is to make sure that the front and the back is very smooth, the intro and the outro of a song, so that if it ever ends up on the radio, then it's like a single. It stands alone. You don't want anything weird where it just cuts off and stuff like that. So that's one thing. Another reason to normalize the audio is if it would be too low, like early CDs, they have a situation. Let's go ahead and just open up another one here. Let's open up One More Night in Audacity, and it should open another one, and it does. This one's a little lower than it needs to be. And when you're encoding to MP3, you really want to get the highest peak level you can before clipping into that encoder so that it has lots of numbers to work with. Because remember, MP3 encoders, they're lossy. They actually throw data away. So the more we put in, the better sounding of a result that we're going to get. So we're going to normalize this as well. And we'll turn it up. So that one is turned up. And let's look at that normalize one more time, because there's a couple of settings there that I want to talk about. If you look here, let me get down and find it again. Oh, it's up here. Right in front of you. Yeah. There it is. You'll notice down here it's got this thing where we can normalize stereo channels independently. I do not suggest you do that. That is not balancing your channels. What that is doing is it is setting a peak balance for the channels where each channel will be at a certain peak level. That does not have anything to do with average audio level or whether it sounds balanced in your ears when you put on headphones. For that, you either need to do that manually, which unfortunately is not easy to do in Audacity. There's probably some way to do this that I don't know, but if you go to Amplify, when we amplify things, it doesn't let us do channels independently, just one channel at a time. There may be a way to select one channel at a time. I don't know. But what I have ended up using in Audacity, and I find this to be quite useful, is loudness normalization. And then here I do set it up to do the stereo channels independently, And I set it quite low. You'll notice it's at minus 17 here on the LUFS. And the reason why that is like that is because I don't want to introduce any peaks, but I want things to be nicely balanced. So let me give you an example of why that is important. And that would be like 60s stereo. You'll find the drums are panned all the way over to one channel and the vocals might be over here. And so the channels appear to be out of balance if you look at them peak to peak. But if you listen to them, it sounds right and everything is where it's supposed to be in the stereo image. A good example of that would be Three Dog Night's Joy to the World. That particular song, the stereo version, over in the left channel, it's just a guitar and an organ and people singing. And over in the right, they put all the drums over there and the main vocals are in the middle. If you look at it on a peak meter from the original record, for instance, you'll notice that the right channel appears to be a lot louder. On some Three Dog Night collections, the engineers saw this and tried to fix that just so it looked right. And then, of course, they screwed up the stereo image. On earlier CDs, the original albums that were released in the 80s and the Three Dog Night Greatest Hits that came out in the 80s, that engineer got it right. So that's the version that I use because on headphones, it sounds the way it's supposed to. While you're in here as well, you can adjust the tone if you want to. Now, I do this extremely sparingly. Like, I usually use bass and treble. I don't get an equalizer up and try and do that garbage. I love this little tool. It's so easy to use. And it's like if I just want to shave a couple of dB off the bass because the engineer who mastered the CD I'm working with that day had a bassgasm, then I can do that. But one of the things to keep in mind here, and this is kind of a rule of digital audio, the less you do to it, the better it's going to sound. Because every time that you change something, you perform math on it, you introduce quantization errors, and if you really process the crap out of a file, what you end up with usually sounds gritty and nasty. You lose a lot of the sparkle. And unfortunately, a lot of the songs that I get these days to put on the air at the radio station, these days I download files from record companies to put directly on the air, and they'll just process the ever-living crap out of it. Once in a great while, I'll get a 9624 high-res file from a record company that I have to dither down to 44.116 to put on the radio station because the automation system, that's what it works at, is 44.116. So that's the house standard. And that's, of course, the CD standard, and that's what we're working with today. So I do not have to convert sample types anywhere. But sometimes I have to do that for the radio station, so I'm very careful about how I do that. The less that you have to do, the better. So if it's passable, let it go. If it's something that's just going to bug the crap out of you, like super boomy bass that's going to stand out when it plays next to everything else, and you can make little changes, but as little as possible. Okay, so it's time to export as an MP3. Let's say that we have our files here, and we have them exactly the way we want them to be. So I'm going to go over here, and I'm going to go to Export, and we're going to export as an MP3. And now we get into one of the big reasons why I like to do it this way with this piece of software instead of using the MP3 option in pretty much any other piece of software out there. And that is that I get very finite control over what that codec is going to do. So first let's talk about bitrate, and here we have variable, average, and constant. A lot of people will say that a variable bitrate MP3 will sound better, and I guess they can, but it all depends on how that is set up, and it depends on your ears, and it depends on a lot of things. I have found that a constant bitrate at a high bitrate is better than an average bitrate as far as giving you a very consistent product on the output. So we go down here and we can look at the different bit rates that we could use. And I use 256. That's pretty close to the top. 320 is the highest you can do for MP3. I don't do 320 in general because it's not compatible with some hardware. There is some older hardware out there that if you tried to play an MP3 file on it, it doesn't recognize 320. That was also 20 years ago. Probably doesn't apply today, but I just use 256 to be absolutely safe. Plus, I think 256 is a good trade-off for file size and audio quality. A 256 MP3 is very hard to detect when compared to the original audio. You'd have to have really good ears and be listening very closely to hear that. Now, when I first started doing this 20 years ago and building music libraries and working with people in radio stations, we kind of came to a consensus, the little group that I was working with when we were building libraries, was that 192 was enough to create an MP3 file that you could broadcast on the air. And that's if you choose the full stereo mode here. Okay? But I went through a period of time where I had software that wouldn't let me select the stereo mode, and it was automatically doing joint stereo. That seems to be the default setting for a lot of software. Joint stereo with high bit rates, you're probably not going to be able to hear a difference between joint and full stereo, so it really doesn't matter. But I prefer full stereo. What is joint stereo? All right, let me see if I can explain this as simply as possible. Okay, with a joint stereo MP3, you take right and left audio from the original file, and we use channel 1 in the MP3 to store left plus right. That simply means that we combine the left channel and the right channel to come up with what in essence is a mono channel, and that becomes left plus right. Then in that same process, we also generate a secondary channel that holds all of the stereo information. That is called left minus right. So what we have created is an audio matrix. And this is how FM radio works. Regular standard stereo FM, not digital. Where the regular FM carrier, it carries the left plus right information, or the mono channel. And then you use a subcarrier to channel the left minus right information, which is all of the stereo information. And then your radio, if it's a mono radio, just plays the FM, so therefore it gets right and left combined. That's mono, you don't miss anything. If that radio has a multiplexer in it, it detects that it's stereo, and then it goes and it demodulates that subcarrier to get the left minus right information, and then that is recombined through a matrix network that turns it back into discrete stereo. That is also known as mid-side, like the middle. Everything in the middle will end up in the left plus right channel, and everything off on either side of the stereo image to the right or left ends up in the left minus right channel. With an MP3, you can use that to your advantage because let's say that you have an MP3 that's 128 kilobytes per second. The encoder can actually take some more of that bit rate and put it toward the left plus right channel because that's more important than left minus right. A lot of times with stereo, everything that's panned all the way to the right and left is going to be lower in audio, less detailed, that sort of thing. And for a low bit rate MP3, that's kind of cool. You know, hey, it makes it sound a little better, which is fine. They use that on streaming audio a lot, like stuff that you stream offline. It's kind of a neat little trick. It makes it sound a little bit better. The downside to joint stereo is that if you have exceptionally wide stereo, let's go back to our example of Three Dog Night, Joy to the World, and the left channel has the drums in it, and then the right channel has just the little organ and the guitar or whatever going. Or if you have a situation where everything is in the right channel and there's nothing in the left channel, then what you'll hear is the stuff in the right channel, and then all of the artifacts from the MP3 encoding process will appear in the left channel with joint stereo. Whereas if you choose full stereo, then the codec goes into a different mode. And what it does is it tries to determine which channel has the more complicated waveform in it, and then it will direct a few more bits toward the right channel, let's say if that's got the drums in it and the cymbals and all that stuff, and then if the left channel has nothing but the little organs and the background voices, then maybe it doesn't get quite as much. And that works out making for a much more natural sounding stereo image, especially with headphones on, and that's why I like to use it. Of course, here we have the option to also force everything to mono, which we don't need to do. We don't need to create mono MP3s, but if you're uploading podcasts or something, hey, that might be very useful. There's another way of doing that, and that would be a dual channel, which we don't have access to here. A dual channel MP3 means that you have just two separate channels that are treated exactly the same, and no audio in one affects the quality of the other. And in that case, it would be if you had a 256 kilobit MP3, or rather, let's do 192. It's easier in my head. Like if the bit rate of the MP3 was 192, it's 296 kilobit streams put together. That's it. That's useful for like audio for video, where you have different languages in each channel and stuff like that. But for music, it's not useful. Plus, if you do things in mono, which is quite interesting. Let's say that you want a 192 kilobit file, then you would, you want that quality, set it to 96. In mono, if you're forcing everything to mono anyway, it'll sound just as good. Because that's really what's happening, because the bit rate is divided between the two channels anyway. So I switched up to 256 from 192 because of joint stereo, just because at high bit rates, honestly, you can't hear that much of a difference between joint stereo and full stereo, but I prefer full stereo. And now you know. So let's go ahead and run this, and it's going to ask me about tag information here. So, I mean, this is the tag that was generated by the Ripper for the FLAC file, and it's going to store it in the MP3 file, and it's ID3 version 2 point something or other that it stores here. So if you want to edit it here, you could, but I'm going to do that with a different piece of software later. So I usually have this turned off. I have it turned on just to be able to show you, because I usually do a batch conversion, right? So let me show you that. We'll do a batch conversion now. And all you do is open up. Let's go ahead and close that. And we're going to do a batch conversion using Audacity. So I'm going to open up Audacity. I have the Audacity to open Audacity. And now what I'm going to do is I'm going to drag in all of our FLAC files that we created. It's fine, FLAC. I just don't want an MP3 file in here. It will happily convert an MP3 back to an MP3 if it wants, we don't want to do that. Matter of fact, you never want to open an MP3 file and then save back to an MP3 unless you absolutely can avoid that, because then you are running it through the MP3 lossy codec twice, and it will end up sounding like crap. So do your editing in a lossless format like WAV or FLAC, and then the very last thing you do is create an MP3. So what I've done here now is I have dragged all of this in here, and it's created a track for each of our files, like that, see? And what I'm going to do, and it didn't take my normalization stuff, but that's okay. That's going to be good for an example I'm going to show you later, because I didn't save the normalization. So I can go over here now, and I can go to export, and I can go down here to export multiple. And on export multiple, you'll see that we have the same sort of setup, but now it's going to export all the files. So I'm going to tell it, don't show me this again, so that we can do this automatically. I usually have that turned off anyway because I never use it. So it's now going to create MP3 files from everything we did, and it should also overwrite the existing MP3 files, because I have it set to do that. We'll double check that. Okay, it said it did it. It gives you a report, and we're done. And that's kind of nice because you can load all your FLACs up, and then if you're just doing normalization, then you can run through and do that, and you can solo each track and get it the way you want it, and then turn it loose if you're doing a whole lot of stuff in a batch. All right, so now we have a whole bunch of MP3 files in here, and the next thing that we want to do is edit the tag information. And I'm going to do this with a piece of software that you probably can't get. It's an old piece of software that I like the workflow on a great deal, and they dropped it from the repositories in Debian and Ubuntu years ago, and I don't think it's gotten any maintenance for a very long time. But like I said, it's a piece of software that I like, and I like the workflow, so I'm going to go ahead and use it because I have I don't require a lot from MP3 files. So let's go ahead and open it up. It's called Tag Tool, and I have a deb file that I keep around that I keep loading up into every new operating system that I put in, and hoping to God that it still works every time. So it automatically found our MP3 files that we created. This is done by directory. So what it does here is that it, whatever directory you select, it just grabs all the files, and then it'll also go through subdirectories. So you can do literally thousands and thousands of MP3 files with this thing. So the first option that we have is setting your file name format. That's important. Remember artist and title. And then here is where we can remove existing tags. And we do this as a one fell swoop, and this removes version 1 and version 2, all of it. So if I download a file from somewhere else, I usually run this first, and I get rid of all of the tag information. Now I'm going to auto-generate a tag from these MP3s, and we're probably going to run into a bug in this software, which I find interesting, which we'll talk a little bit about when we get there. And now that I have generated the tags, and by the way, I only generate version 2, not version 1. Version 1 tags have a limited number of spaces in the database for titles and artists and things like that, and that's not cool. So let's take a look here. And you'll see that the only thing I have in my tag is the title and the artist. That's it. Why not the year? Because the years are usually provided by the database, and what's in the database is the year the CD is released. So it doesn't have anything to do with the song. What year did this song originally come out? 83? Well, the disc that I took it from probably came out in 94 or 95, so it would say 94, 95 on there. It won't work, so I don't bother with it. You can go through and manually change that if you want to, but I don't bother with the years. So this way I can just check and see if everything's all right. And here's a little problem that you can see, that this particular piece of software does not like the apostrophe there, because it's not really an apostrophe. It's a tick mark. They do that in these databases to avoid problems with file systems saving them later. So in that case, usually what I do is just rename the file. So I'll go to Properties. Now I'm going to rename this file, and I'm going to put a real apostrophe in here. This thing will also do that with hyphens that aren't hyphens. They're just like dash marks. I don't know what they're called. So then I will go ahead and run Tag Tool again, and we will fix that problem. This is probably something that you will never have to deal with, because you're not going to use this piece of software. You're going to go get a more modern tag editor, and you're going to learn how to use it, which I'm too lazy to do. So let's go through the process again. We'll just delete all the tags. It's no big deal. Generate new tags. Go. And of course, if I was doing this with hundreds of files, then I wouldn't do that. But I'm just doing that to be pedantic here and show you. So now that works fine. So all of those are good. So now we have MP3 files that we want to add to our collection. Cool, huh? So what's the next step? Now we want to set the average loudness. And this is a little tool that I have used for many, many years, and I have fought hard to keep it in the Linux repositories. For a while it went away. It left Debian, and then Ubuntu didn't have it. And so I was hanging on to old Deb files. Martin Wimpress, who is the head developer for Ubuntu Mate, he maintained this in a ppm for one of those PPA for Ubuntu things. I almost said ppm, peak power meter is what I was thinking. PPA for a while, and it's also available as a snap in the Snap Store, and it is back in the regular repositories for Debian and Ubuntu, and I think it's because I yelled so loud in so many videos through the years that they put it back, so thank you. So I'm going to open this directory in a terminal, which is just right-click and choose that, or you can just open a terminal and navigate to whatever directory your crap is in. And what I'm going to do here is make this bigger so that everybody can see even on low-res devices. And the piece of software that we're going to use today is MP3 Gain. We'll take a quick look at the man page for it, and it kind of describes what it does. This will adjust the playback gain of our MP3 file in the MP3 file itself. It does this on every frame of audio in an MP3. This is different from setting replay gain like in Rhythmbox or some other thing. That just puts something in the tag to tell the player what to play. No, this will work with any hardware or anything that it plays in later on. And the nice thing about this is the fact that we're not actually going to be losing any data. So if you take a WAV file and you turn it down 5 dB to set an average level on it, you've lost 5 dB of resolution, because what you're actually doing is you are moving the bits down. So the lowest bit in the digital word that describes how loud a sample is called the least significant bit, and the one up top is called the most significant. The least significant bit is the first step between silence and there might be something here. When you drop the entire thing down 5 dB, you move that least significant bit up, and everything below it just gets truncated. It's not there anymore. You actually reduce the resolution. So watch your gain changes with WAV files. Make sure that you're always going up if you can. And if you're going down, do it once and don't do it again. Because when I import stuff into the radio station stuff, what I end up usually doing is setting the peak level to -3 if it's heavily processed, and if not, then I'll just do an average of -3 if I can get away with it. And I'm actually changing the level in WAV files, so I'm very careful about how I do that and how many times I do that, because every time you lose data. So this does it in such a way that we could actually go back later and reset it. Don't do that, Joe. Use it properly. The proper way to get out of a man page is Q, not to close the terminal like that, dude. Besides, we need the terminal. See, I do stupid stuff like that when I'm talking and trying to run a keyboard at the same time. Anyway, we're going to use this piece of software, and the way it works is it will act on any files in the directory that you run it in. I have not found a way from the command line to tell it to dip into subdirectories. When MP3 Gain was first introduced back about 20 years ago when I started playing with it, it had a Windows wrapper that had a GUI. It was point and click, and the same thing in Linux. Unfortunately, that went by the wayside, and the only way we can do this in Linux today is from the command line, because I don't think that the GUI part of it, the front end, has survived through the years. It wasn't that great for Linux anyway. You're not missing anything. And besides, what we want to do with it is really simple. I'll show you. It's MP3 Gain, and then we want to choose R, which tells it to set an average level, and then we want to use K. Now what K will do is make sure that the file does not get clipped. So if you have a file that's extremely wide dynamic range, let's say like an original CD pressing of Billy Joel's The Nylon Curtain, and there's the song Goodnight Saigon. That's not going to be able to be averaged. It's going to try and turn it up too loud, and the really loud parts are going to be clipped. And so what this does is it kind of heads that off at the pass and goes, okay, we can't do that. And then it does like a normalization where the peak volume is right set up at 0 up top, and we won't get any clipping on playback. And then we need to tell it what to look for. You could put in individual files. You could use wildcards or whatever. What I put in is just star the glob there. That means everything before that, and any file that ends with 3 in the extension. And that'll work perfectly for what we're doing. So let's turn it loose. Enter to go. And you see that Look of Love by ABC is really loud. So it went down to -6. And then 4 for Gary Newman, 2 for Don't Lose My Number, 1 for Phil Collins' One More Night, and 1 for whatever. If you see it actually turn it up, that means that the original audio on your MP3 file is extremely low. And if it's one that you just generated, then I would go back through the process again and get the FLAC file and normalize that before you encode it with an MP3 codec to make sure that you have all the resolution there, and then run that again. So that's done, right? So we're done. We have all of our files. We have ripped them, named them properly, generated tags. We've the way I like to do tags. You don't have to do it that way. And then I have set the gain. So these are done, and we can drag these off into wherever you put your files for your music library, right? And we'll talk a little bit more about that here coming up, because we're going to get into Rhythmbox in a minute. So now we can get rid. Oh, I forgot. Let me do this. We can get rid of the FLAC files super easy. So it's rm star FLAC, and they go poof. All right. So now we just have the MP3 files. So where do you put them? Well, it depends on how you have your library set up. If you're not going to be doing thousands and thousands of songs, maybe just a single directory with a bunch of songs in it is fine. Maybe you would like to have it where each CD has its own little folder. You could set it up that way when it was ripped. I personally just divide things up in my library here. Let's go to music. And I just, have these really broad divisions. Here's country. This is a Christmas tunes. I have more pop than anything else in here. And so I have that by decade, 50s, 60s, 70s, 80s, 90s. It's rock and roll era, basically. And I don't have a great deal of stuff in modern because, honestly, I don't give two craps about music after about 2003 or so. I don't care. Except for certain artists that I follow. So that's the way I do it. You can do it any way you want to. What's nice is that most music players will look at whatever directory structure you have in the folder where you have music, and it will kind of just go down and read through all of that. And that's what we're going to get into here in just a second. I did want to show you one of the reasons why MP3 gain is so important. First of all, you have my library there. There's about 6,000 songs in there and pieces of music. Some of it's classical, some of it's quite long. When MP3 started to become a thing in the early 2000s, I was working with a bunch of program directors at radio stations on the East Coast, and the idea was floated that we should create a big database that has just about every song that ever hit the charts in it. And I had a friend of mine named Mitch Allen who was involved with this project, and he let me be a part of it, so I contributed to it. And by the way, at this time, this was perfectly legal because we were all working with BMI and ASCAP licenses because we weren't distributing them to the public. We were setting this up for playback on the air, right? So anyway, I have a copy of this library. So if we pick a year, let's just do 1972. Look, all of these MP3 files, they've all been set with MP3 gain, every one of them. The files in this library do not have any tags on them. And some of them aren't the greatest quality because it was a never-ending project. And what they would do is they'd find a file that at least sounded like the right song but didn't necessarily have the greatest audio quality and throw it in there as a placeholder. And so they're all not like super high quality. But I keep it around as a reference, and every now and again I'll find something in there that's just incredibly difficult to find anywhere else. So yeah, that's why it's so important to me. So we have created these files, and I am going to go ahead, now that we have done this, I'm going to delete everything out of this directory, and that is because I'm going to show you a simpler way to do this with the Rhythmbox program, which is widely available on just about every Linux distribution there is. It's part of the GNOME desktop, and it's a very nice little piece of software. So let's hope this opens up properly, because in past takes I've had issues. So with Rhythmbox, when you first install it, you have to tell it where your library is. And in this case, what we're going to pretend is that we don't have a library. And we're going to set this up to create MP3s for us. So let's go to Preferences, and then we go to Music right here. And right now I'm telling it the library lives in Work. In reality, the library that I usually use with this lives in the Music directory. So I will switch this back when we're done. Now, Rhythmbox will rip audio into different formats, and it really wants to put it in a directory when it does it. So I have this set just for album. That's all it is right now. And then, of course, we've chosen artist title. Now, if you're actually going to be ripping CDs and you want to keep track, you might want to choose a different format. I'm just going to do artist and title. We've chosen MP3. Once again, we have chosen constant bitrate. Okay. And if it goes here, it says default settings and constant bitrate. So it doesn't say what the defaults are, but we can choose variable. There it is. Okay. Constant bitrate. And once again, we're doing 256. It does not give me control over whether it's going to be full stereo or joint stereo, so I don't know. So I'm going to assume here that it's joint stereo. That's one of the reasons I'm going to do what I'm doing. And I'm going to close that. That's fine. And now we'll put a CD in it. And we'll rip some tunes and show you how easy it is. So let's put a disc in. And it'll take a couple of seconds to figure out that it's there, as usual. And it should list it over here somewhere. I have a bunch of playlists that I've already created, and they're null and void now because I like active playlists, which is where you set up a criteria and it goes and searches for it. So anyway, here's our disk. It did find the CD. It found information. And it's just pretty much the same thing. We can just extract, let's do, let's do The Look of Love again. We'll just get one song off the disc because of time. We're going to extract this. I hear it spinning up, so here we go. Now what you could do is just, like I said, create these in a directory and then drag them out and put them in the directory if you didn't want to have them in individual. You could do all kinds of ways. And this brings up another feature of MP3 gain, which is it will also set album gain. And what that means is that you can take a group of MP3 files and say, okay, this group of MP3 files all belong to the same album, so set an average level across all of those MP3 files. All right, that's done, so I'm going to eject it. Okay, we've got that done. And we'll just do one file. So it's already showed up in our library that we have this here. And if we actually go and look at what we've got in the work directory, you'll see that we have the directory has appeared for our disk, and we have the song in there. And we can open this up with, let's open it in the directory here. I'm going to do tag tool from here. And I'm going to go and I'm going to browse for this directory because and we're going to look and see what it did with the tag file here. So it created an ID32 tag file, right? And it said this disk came out in 1992. You can change that by hand. There's no ID31, so that's cool. We'll leave the tag in place. And now let's run MP3 gain on it. Boom, done. Now that's in your library. And we did 90% of what's done before, and I'm sure this will sound very nice indeed because it's using the same lame codec. It may be joint stereo, but it'll be all right. So there you go, boys and girls. That is how I manage and create MP3 files for my system. And I hope you learned something from this, got something out of it. If you like the video, be sure and put a like on it. That helps a lot. It lets YouTube know that people do like the video. And share it with your friends because the algorithm is unfriendly to long-form videos these days. And so the more you share it, the more people see it, the better it is for my channel, and I appreciate that. I'm looking forward to your comments and suggestions. Thank you for watching. We'll do it again soon.